It's Mrs. Mafucci, and it's time to look at the classification of matter. We're going to consider mixtures, substances, elements, and compounds. So right now, take out your reading notebook and take notes on the right side of your notebook. The first thing we're going to look at are mixtures. Mixtures are defined as a physical combination of two or more substances, each of which retains its individual properties. The composition of mixtures can vary. In other words, there is no formula for a mixture. The components of a mixture can be separated by physical means. Let's look at the following mixture and see how we can separate the components. Consider how you would separate the components of a mixture containing sugar, sand, and water found in beaker 1. The first thing you might do is heat it up. By heating it up, what would dissolve? The sugar or the sand? Well, you guys would probably guess that it's the sugar that's going to dissolve in the water and the sand will remain undissolved. That means in the third figure, you could filter out the undissolved sand into a piece of filter paper and the sugar water would go through. And then finally, in number 4, we could evaporate the water, leaving the sugar behind. Stirring, heating, filtering, evaporating are all physical processes. The components of a mixture can be separated by physical means. Well, how do we classify mixtures? It's based on how the components are distributed. So let's look at 2 different types of mixtures. There's heterogeneous mixtures. Hetero meaning different. There is an uneven distribution of the components. Take a look at that picture. Uneven distribution of the components. As compared with a homogeneous mixture where there is an even distribution of the components. Look at that figure. Heterogeneous, homogeneous. Look at that Greek salad. That is definitely a heterogeneous mixture. Notice that the components are not evenly mixed. Notice that there's more than one phase. You can see the borders between the components of the salad. The individual components are clearly visible in a heterogeneous mixture, and there are different properties within the sample of the mixture. In other words, one biteful might have a lot more tomatoes than my next biteful, which may be a lot of cucumbers. Well, what about homogeneous mixtures? Perfume would be an example of a homogeneous mixture, made up of many different components evenly distributed. There's a uniform composition, and there's only one phase. You can't see the individual components of the perfume. It looks like it's only one thing. Homogeneous mixtures are uniform and have consistent properties. A homogeneous mixture is called a solution. A solution is made up of a solute and a solvent. A solute is the component that gets dissolved. It's found in the least amount. The solvent is the component that does the dissolving. It's found in the greatest amount. Well, now, how do we classify substances? A substance is not the same thing as a mixture. A substance is homogeneous matter with a definite composition or chemical formula. The first kind of substance are elements, and the second kind are compounds. Elements and compounds are substances. Let's look at elements first. Elements are made up of one kind of atom. Elements are represented by symbols. Elements cannot be broken down by ordinary chemical means. The figure in the lower right-hand column represents an atom of sodium. Na is the symbol for sodium. This figure represents an atom of carbon. The symbol for carbon is C. Now, there's such a thing as diatomic elements. There are 7 elements that form diatomic molecules. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. When you write the formula for hydrogen, nitrogen, oxygen, fluorine, and chlorine gases, you always have a subscript 2. Bromine is a liquid and iodine is a solid. It's important for you to memorize the diatomic elements. All of the other elements on the periodic table would be considered to be monoatomic. Let's look at compounds. Compounds are made up of 2 or more different kinds of atoms chemically combined. The atoms combine in a definite ratio. In other words, compounds have a definite composition and are represented by formulas. For example, you all know that water is H2O. Water always has 2 atoms of hydrogen for every 1 atom of oxygen. The properties of compounds are different from the properties of the elements that make them up. In other words, water has different properties than hydrogen gas and oxygen gas. Let's consider 2 different compounds. Iron, which is a metal, plus sulfur, which is a nonmetal, forms the compound iron sulfide. And as we previously discussed, hydrogen plus oxygen forms the compound water. There are 2 hydrogens for every 1 oxygen in water. Compounds have a definite composition. Let's consider these 4 diagrams that represent compounds, elements, diatomic elements, and a mixture of elements and compounds. Let's see if we can determine which is which. Let's look at the figure in the upper left-hand corner. Notice that the diagram represents 2 circles, 2 atoms of the same color connected to one another. In other words, there's a chemical bond between those 2 atoms. This would represent a diatomic element made up of molecules. Now let's look at the diagram in the upper right-hand corner. Well, hopefully you can see that that's a compound. And that compound is made up of 4 atoms. Notice that 3 are green, 1 is purple. This represents a compound also made up of molecules composed of 4 atoms of 2 different elements. Let's look at the diagram in the lower left-hand corner. Single red spheres. This would represent atoms of an element. And since there's only 1 red sphere to represent the element, we say that it's a monoatomic element. Now let's consider the figure in the lower right-hand corner. Hopefully you notice the red monoatomic element. You notice the blue diatomic element, and then the compound made up of 4 atoms, 3 atoms of the same element, and 1 atom of a different element. This would represent a mixture made up of a monoatomic element, diatomic element, and compound. The next figure represents a way of classifying matter. Matter can be separated into pure substances or mixtures. Remember, pure substances have a definite composition. Elements and compounds are pure substances. Mixtures can be separated into homogeneous mixtures, which are called solutions, or heterogeneous mixtures.